So dear students, in our last section we have seen the requirement engineering phase of the waterfall model, and in this section we will see the design phase of the waterfall model. So the design phase is the second phase of the waterfall model. So for designing phase we have to consider two designs, hardware and software. As we know, embedded system is what? It is collection of hardware and software. Why? Because it gives us the specific output, and for that the collection of hardware and software is used. Now as the collection of hardware and software is used, we have to consider the designing and implementation of hardware as well as software. So in this phase we are designing the hardware as well as we are designing the software also. So first we will study what are the designing goals. So the designing goals are to meet all the functional and performance requirement. Functionality and performance is the main important part of any embedded system. So the first design goal is it should meet all the functional and performance requirement. Now each and every embedded system is having its unique and different functional and performance requirement. So according to that particular system, it should meet the functional and performance requirements to reduce the size and cost of the system to the extent possible. Now we have seen that why embedded system is widely used, because mainly it uses or it's based on the chips, and because of the on chips the size is very compact of any embedded system, and that's why the main design goal is to reduce the size as much as possible as well as cost of the system as much as possible. It's very desirable to have the smallest embedded system and the cost should be minimum. That is one of the design goal. To reduce the power consumption of the system. We have seen this is also the functionality of embedded system, that it requires the less power consumption. So whenever we are designing any system, so we have to consider that whatever system we are designing, it should need the less power. So for that the main design goal is to reduce the power consumption of the system. To reduce the development time and effort. Whenever we are finding the cost of any project, we know that in that the time and efforts are also included. So if we are having the particular development in the smallest time and smallest efforts, then that is desirable. So that is also one of the goal to reduce the development time and effort, to reduce the maintenance effort and time. Now, whenever we are developing any system, the maintenance, operation, and maintenance plays the main role. Why? Because if you are whatever system you are having, its performance is very good, but if its maintenance is very high, then it's not the acceptable thing. So whatever we have designed, its maintenance should be also required less time. So that is also one of the goal, to reduce the maintenance effort and time. To increase the reliability. Yes, whatever system we are having, that should be as much highly reliable as possible. So the main important design goal of any embedded system is whatever system we are designing, it should be highly reliable. So these are the designing goals. Now the next is design trade-offs. Means which processor we are going to use. We know that mainly which processors are used: microprocessor, microcontroller, and digital, that is digital signal processor. Whenever you are whatever requirement you are having, according to that the processor is choose from the microprocessor, microcontroller, and the DSP. So the design trade-off contains, out of these three, which processor we are going to use for our system. Is an FPGA required? Is it necessary to have FPGA for our system? That is also one of the trade-off. Is it necessary to embed real-time OS on the target system? Now we know that time constraint is crucial in some embedded system, and it's not that much crucial in some embedded systems. So we have to check that is it necessary to embed the real-time OS on the target system. Listen, we are saying target system, not host system. Why we are saying target system? Because whatever we are designing, we are mainly designing it for the target system, and that's why we have to consider that what is the requirement of the particular target system. So it should be necessary to know that it's required to embed the real-time OS on the target system. So the design process can be divided into two parts: hardware and software design. As the design is divided into two parts, it is also called as hardware and software partitioning. As the designing is having these two partitions, it is also called as co-design, and that's why it is called as the hardware software partitioning or co-design. That is nothing but hardware design and software design. So whenever we are implementing the hardware or software, we have to consider the following issues. That is the speed of execution. It's highly desirable to have the highest speed of execution, so that we should consider flexibility for making changes. Whenever we are building any system, we should make the system in such a way that if changes are required, then that should be easily adapted in that system. And that's why it should be taken care of that whatever system we are building, it should be flexible for accepting the changes. Size should be as compact as possible, as I already said. Power consumption is also less. It's desirable to have the less power consumption. Memory cost. Memory is also used according to its need. Whatever requirement of our system, according to that, the memory is used from RAM, ROM, or its hybrid types. Cost. It's desirable to have as much less cost as possible. So, whenever we are designing or implementing the hardware and software, then these are the issues which we have to consider. So, whenever we are building any system, any embedded system, that consists the hardware and software, and both are having their own design and implementation. So, for having the highest reliability output, these are the features that are taken into consideration. So Intel's when we are thinking about the processor, Intel's 80386 is an integer only processor and 387 is floating point processor. So as I said, according to the need of the system, the processor is chosen. So this is nothing but design and the co-design. The design is the main phase, second phase of the waterfall model, where the design is divided into two parts, that is hardware and software partitioning, that is co-design. In this co-design, which issues should be considered, that we have discussed, and in our next section we will see in detail the co-design, that is nothing but the hardware design and software design. Thank you.